Okay, now we are going to start talking about the trig, but first we are going to talk about the trigonometric ratios in a right triangle. Just a couple of definitions. Remember, the hypotenuse in a right triangle is the side which is opposite to the right angle. And in a right triangle, the longest side is always hypotenuse. Now, I'll give you an example is a triangle like this, which I showed a 90 degrees angle with a square here. And the side which is in front of it, which is this side, is called the hypotenuse. So the side, let's say, AC in the triangle ABC is the hypotenuse, which is in front of the 90 degrees angle. And this is the longest side in the triangle ABC. Now, in any right triangle ABC, if you recall, the Pythagorean theorem says that the square of the sum of the squares of two sides is equal to the square of the hypotenuse. Okay? The other two sides, we call them legs. So this one and this one are called the legs. So the sum of the squares of these two legs, which is b squared and a squared, is equal to the square of the hypotenuse, which is c squared, which is this side. Now, one warning I have to give you is that usually the students, they memorize c squared is equal a squared plus b squared. This is not always true because the naming of the triangle may be different. What you have to memorize is the hypotenuse squared is the sum of the square of the other two sides or the two legs. So do not memorize a squared plus b squared is equal to c squared. Because in this triangle, if c is one of the legs, then the Pythagorean theorem changes. So the first example, we have a right triangle. One side is 15. The hypotenuse is 21. We are supposed to find side B. By definition, Pythagorean theorem, it says that b squared plus 15 squared is equal to 21 squared. Now, to find b, I'm going to isolate b. So I'm going to move 15 squared to the right. It's going to change sign. So I'm going to have b squared is 21 squared minus 15 squared. Now, what is 21 squared minus 15 squared? 216. Thank you. Now I have b squared is equal to 216. To find b, I do the opposite operation. Square, the opposite of square is square root. So I take the square root of both sides. I get b is approximately 14.7 feet. Okay, in this example, I have a soccer field which looks like a rectangle, and I have to find the measure of the diagonal here. I know one side is 90, the other one is 45. Since this is a rectangle, I know that if this is 45, so this means that the side opposite to it has to be 45 too. Now, in the triangle NML, this angle, it is obvious 90 because of the rectangle inside it. So I can use the Pythagorean theorem. I can write that 90 squared plus 45 squared is equal to ln squared. Now, use your calculator. 90 squared plus 45 squared is, anybody? 101.25. Thank you. Is ln squared. Now, the opposite of squared is square root. So I take the square root of these two sides, and I get ln is approximately 100.6 meters. Did you get the same thing? Yeah. Yep, thank you. So the primary trig ratios are sine, cosine, and tan. Okay? If you guys remember from grade 10, the acronym was SOHCAHTOA. This was the one which was helping you to memorize all these three ratios. Now, if you remember, S stands for sine, O stands for opposite, H stands for hypotenuse, C stands for cosine, A stands for adjacent, H stands for hypotenuse, T stands for tan, O stands for opposite, and A stands for adjacent. Now, how do you use the acronym? Was very simple. You would say sine is equal to opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. But again, I emphasize, this is only valid for a right triangle. How do you know it's a right triangle? Either it says 90 degrees here, or you will see a rectangle here. Other than that, do not assume it's a right triangle, even if it looks like a 90 degrees angle. Now, just to give you the formulas, these are the primary trig ratios. Sine A is opposite divided by hypotenuse. Cos is adjacent divided by hypotenuse, and tan is opposite divided by adjacent. Now, if you look at this triangle ABC, for sine A, opposite is the side which is in front of it, which is CB, divided by hypotenuse, which is AB. But it is customary, we label the sides corresponding to the lowercase of the vertex. Since this side is in front of vertex A, we assign lowercase a. This side is in front of C, we assign lowercase c, and AC is in front of B, we assign lowercase b. Now, when I write the trig ratios, I'm going to write sine A opposite, which is this side, which is BC, which is A, divided by hypotenuse, which is C. And so forth for the other one, cos and tan too. But again, I emphasize, you have to have a right triangle. If you don't, do not use these ratios. They don't mean anything. Okay, in this example, I have a triangle MNP, which is right triangle because of the rectangle or the square at angle A. The angle P is 60 degrees. I'm supposed to find side P if MP, which is the hypotenuse, is 225 feet. Now, whenever you have a triangle like this one, look at the information given. You have angle, opposite to angle, assuming that P is given. So I know angle, opposite, and also I know hypotenuse. So if I look at the trig ratios, angle, opposite, hypotenuse is sine, because sine is opposite over hypotenuse. So I can use the following formula. Sine 60 is equal to opposite, which is P, over hypotenuse, which is 225. Now, if you remember the reviews, we have to solve this linear equation in P. Remember that the denominator of sine 60 is 1, so I can crisscross. So I can say P times 1, which is P, is equal to 225 sine 60. Now, using your calculator, you can find what is 225 times sine 60. But before you do that, make sure your calculator is set to degrees. It's not radian. Otherwise, again, your answer is going to be incorrect. So what is 225 times sine 60?
Well, 194 or 194.9, or I guess 195.
Okay, 194.9 meters. Oh, I'm sorry, feet. Because the unit is in feet. So you can use sine minus 1, cos minus 1, and tan minus 1 to find the value or the measure of the angle if the sine, cos, and tan of the angle is known. How do you access these functions? Is using usually second sin, second cos, and second tan on your calculator. And the return value is going to be the angle either in degrees or radian. So for example, if I ask you if sine of an angle is 0.75, what is that angle in degrees? So go ahead. If sine alpha is 0.75, what is alpha? So if you do this one, then you get alpha is about 48 degrees. Now, there are two definitions very, very important in your word problems. One is called angle of elevation, and the other one, angle of depression. So let's see what exactly is angle of elevation. Angle of elevation is the angle that your line of view makes with the horizontal, okay, if you are looking up. So if I have to look at the top of a building, my line of view, the angle that it makes with the horizontal is called angle of elevation. So angle of elevation is elevation, remember elevator going up. So angle of elevation is when you look up there, not down, up. And your line of view makes with the horizon is called the angle of elevation, as it is shown here in the diagram. So this angle is called angle of elevation. And you are viewing this object here, which means that you are looking up there. Now the second one, which is very important, is angle of depression, which is the same idea as angle of elevation, but the difference now is that you are looking down. So if I'm looking at the bottom of a building, okay, my line of view is going to make an angle with the horizon or a horizontal line. That angle is called angle of depression. Okay? So this angle here is angle of depression, and the object is down below the line of view. So angle of elevation is when you look up, and angle of depression is when you look down. From grade 10 is to solve a triangle. Solving a triangle, which is a little bit more involved than any other operation, is to find all the interior angles and all the measure of the sides. So if I give you a triangle and I ask you to solve the triangle, you have to find this side, and this side, and you have to find this angle, and this angle. Now you may think that it's going to be a lot. No, I mean, enough information is given that you can go ahead and solve the triangle. Now, the example I've given you is not a right triangle. Doesn't matter, I mean, right triangle or non-right triangle, still you can solve the triangles. So the next example is a word problem which says that Michel is drawing a map of a triangular plot of land The measurements are given, 1.2 kilometers and 1.8 kilometers. Determine the angles in the triangle. Again, there are three interior angles, A, B, C, you have to find them. And determine the bearing of the third side of the pilot, AB, meaning that you have to find the angle A on the top. So these are the things you have to find. You have to find this angle, this angle, this angle, and also this angle. So go ahead. Okay, to find, let's say, start with angle C. We know that C is 90 degrees. It's given in the diagram. To find angle B, I'm going to use the information given. Assuming angle B is given, I know angle B, the side opposite, and the side adjacent to angle B is known. So angle opposite adjacent, I have to refer to SOHCAHTOA to see which trig function represents angle opposite adjacent. And that ratio is tan. So I can say tan B is equal to opposite, which is 1.2 divided by 1.8. Now, if you use the inverse function on your calculator, you will get that angle B is equal to, how much? Did anybody find it? Use second function tan, 1.2 divided by 1.8. What do you get? 40, 45, 33.7? Okay, so B is 33.7 degrees. I also know C is 90 degrees. Now, there are two ways I can find A. Either I use the fact that the sum of the angles inside the triangle is how much? 180. Inside the triangle, the angles, the sum of the angles is 180. So I can say that angle A plus angle C, which is 90, plus 33.7 is 180. Then I'm going to move 90 and 33.7 to the right, becomes negative. So A becomes, how much is A? 56.3 degrees. So I know what is angle A, what is angle B, what is angle C. The only thing now I have to find for part B is how much is this angle outside angle A. How do you find that angle?
A squared plus B squared equals C squared.
No. I want to find this angle here. A squared is equal to B squared plus C squared is Pythagorean. I don't want the sides. How do you find that angle? I'm sorry?
It is the same 56.3.
Why?
Because the rule like I don't know.
Okay, this is called, if you remember from grade 9, this angle is called a straight angle. This angle is a straight angle. How much is a straight angle? 180. I know the straight angle is 180, and I know angle A is 56.3. So how do you find the exterior angle? Excellent. So I can say this angle is 180 minus 56.3, which is equal to how much?
123.
117?
123.
123.7. Thank you. So the angle is 123.7. Okay, again, as I said, the convention is the sides in front of every vertex, they get the lowercase letter of the vertex. So this is B, this is A, and this is C. Now, sine, by definition, is opposite over hypotenuse. So for A, I say that sine A is equal to opposite, which is A, divided by hypotenuse, which is C. So that's sine A. cos A, by definition, is adjacent over hypotenuse. Adjacent is B divided by hypotenuse, which is C. Cos B, the same way, is adjacent, which is A, divided by hypotenuse, which is C. And tan B, for this angle, is opposite, which is this side, which is B, over adjacent. I can't say C is the adjacent because this is hypotenuse. So A is the adjacent to angle B. So it's going to be B over A. Okay, again, I look at what information is given. I know the angle is given here. I know the side in front of it, which is required, assuming that this side is given. And also I know this side, which is the hypotenuse. So in this problem, angle, opposite, hypotenuse are given. Okay? So going back to the ratios, the one which is the one that I can use here is sine. So I can write sine 25 is equal to E over 3.4. Now, to solve this one again, the denominator here is 1. I'm going to crisscross here. So I'm going to say E times 1 is E is equal to 3.4 sine 25 degrees. Now, if you multiply 3.4 by sine 25, you get, what do you get? 3.4 times sine 25. Arjun, what do you get? 1.44. So the answer is 1.44 meters, assuming what Harjot said is correct. Okay, in the next problem, I have to find Q. I know the angle, assuming side Q is already known, which is opposite. And I know this side, which is the adjacent. So angle, opposite, adjacent. Again, going back the trig ratios, angle, opposite, adjacent is tan. So I'm going to say tan 13 is equal to opposite, which is going to be Q over adjacent, which is 103. Again, I don't care about the unit here. So tan 13, the denominator is 1. Again, I'm going to crisscross here. Q times 1 is Q. 103 times tan 13. And 103 times, how much?
23.
Is going to give you 23.8 meters. Okay, in this example, first of all, it's a right triangle, so I can use the trig ratios. Second, this angle is given. This side is adjacent to the angle. And assuming this side is given, which is hypotenuse, so I have angle adjacent hypotenuse. One of those trig ratios is cos, which says cos of any angle is adjacent over hypotenuse. So I can write cos 43 is adjacent, which is 43, divided by hypotenuse, which is g. Again, the denominator is 1. I crisscross here. I get 43 times 1 is 43 is equal to g times cos 43. Now, since I have to find g, I have to get rid of cos 43. To get rid of cos 43, I'm going to divide by cos 43. So I get g is 43 divided by cos 43. And how much is it?
58.8.
58.8, thank you. 58.8, sorry, feet. Or inches, sorry, inches. Now, just to double check, remember that hypotenuse is the longest side in any triangle. G is 58.8, which is greater than 43, so we are okay. Although we haven't found the value of GF, but we can assume that it's going to be less than 58.8.